Right now, as you're processing these words, as neurons fire and patterns form in your brain, you are creating something that has weight. Your thoughts are not immaterial wisps floating in some ethereal realm. They are physical structures with measurable mass. Information itself is physical, and every time you think you are rearranging matter in ways that change the gravitational field of the universe, however slightly. This isn't philosophy, this is physics. Let me show you why information is as real as atoms, and why consciousness might be the most physical thing there is. For centuries we've treated information as abstract. Numbers, ideas, memories, knowledge, these seem to exist in a different category from rocks and water and electromagnetic fields. The physical world was made of matter and energy. Information was something else, a description we imposed on physical systems but not itself a physical entity. This separation seemed natural. You can write the same number on paper or encode it in a computer or remember it in your brain. The information appears independent of its physical substrate. It seems like pure abstraction. But 20th century physics destroyed this distinction. Information turns out to be deeply physical. It has energy. It occupies space. It obeys conservation laws. And most remarkably, it has mass. The first hint of this came from thermodynamics. In the 1860s, James Clerk Maxwell proposed a thought experiment involving a tiny demon who could sort fast and slow molecules in a gas. This demon appeared to violate the second law of thermodynamics by decreasing entropy without doing work. The resolution came a century later. Leo Szilard and later Rolf Landauer showed that the demon must store information about which molecules are fast and slow. Eventually, the demon's memory fills up and must be erased. Erasing information requires energy. The energy cost of erasure exactly compensates for the entropy decrease the demon achieved. This revealed something profound. Information is not free. It has a thermodynamic cost. Landauer proved that erasing one bit of information at room temperature requires a minimum energy of about kT log 2, where K is Boltzmann's constant and T is temperature. This energy cost means information has mass through Einstein's relation E equals mc squared. The mass is incredibly tiny. Erasing one bit at room temperature corresponds to a mass of about 10 to the power of minus 32 kilograms. But it's done go. Information literally weighs something. Now let me make this concrete for your brain. Your brain contains roughly 86 billion neurons. Each neuron can be in various states of activation and forms thousands of connections with other neurons. The total information storage capacity of a human brain is estimated at somewhere between 1 and 10 terabytes. A terabyte is roughly 10 to the power of 13 bits. If your brain stores 10 terabytes of information, and each bit has mass according to Landauer's principle, then the information in your brain contributes approximately 10 to the power of minus 18 kilograms to your total body mass. That's about a femtogram, utterly negligible on any practical scale. You will never measure this on a bathroom scale, but it's real. The configuration of information in your brain has gravitational mass. It curves spacetime around you by an amount that depends on what you're thinking. When you learn something new, when you store a memory, you are increasing the mass of your brain by a minuscule amount. When you forget, when neural patterns decay, you are losing mass. Your thoughts have weight, but the story goes deeper than this simple calculation suggests. Because information is conserved in fundamental physics in a much stronger sense. Quantum mechanics is built on a principle called unitarity. It says that the total information content of a closed quantum system never changes. It can be scrambled, spread out, encoded in subtle correlations, but never destroyed. This is why black holes created such a crisis in theoretical physics. Stephen Hawking showed in the 1970s that black holes emit radiation and eventually evaporate. But the radiation appears to be purely thermal, carrying no information about what fell into the black hole. If the black hole evaporates completely, where did the information about all the matter that formed it go? Hawking argued the information was destroyed, lost forever behind the event horizon, and then radiated away as structureless heat. This violated unitarity. It meant quantum mechanics broke down at black holes. I disagreed with Stephen about this, and we had a famous long-running debate. I argued that information cannot be destroyed, not even by black holes. General relativity and quantum mechanics might both need modification, but unitarity had to be preserved. Eventually Hawking conceded. He accepted that information must somehow be preserved even in black hole evaporation. The exact mechanism is still debated, but the principle is clear. Information is conserved because it's a physical quantity as fundamental as energy or momentum. This has radical implications. Every thought you've ever had, every configuration your brain has passed through, that information still exists somewhere in the universe. It's encoded in the photons that radiated from your body, in the heat you expelled, in the molecules you exhaled, in the gravitational waves that propagated from the mass rearrangement in your skull. The information is scrambled beyond any practical recovery. But in principle, if you could track every particle and quantum correlation in the universe, you could reconstruct every thought every human has ever had. The information is there. Now let me connect this to consciousness in a way that might surprise you. I've long argued that consciousness cannot be explained by classical physics alone. The brain is often compared to a computer, processing information through deterministic or probabilistic algorithms. But I believe consciousness involves something genuinely quantum mechanical. Classical computation can be simulated by other classical systems. There's nothing special about silicon or neurons in principle. Any classical computer can emulate any other. If consciousness were purely classical information processing, there would be nothing preventing a sufficiently complex simulation from being conscious. But quantum information is different. Quantum states cannot be copied or cloned perfectly. Quantum entanglement creates correlations that have no classical analog. Quantum superposition allows systems to exist in multiple states simultaneously until measured. If consciousness involves quantum information processing, specifically in structures like microtubules inside neurons, then it cannot be replicated on classical hardware. Your consciousness would be fundamentally quantum mechanical, involving genuine superposition and entanglement of information states. And if that's true, then your thoughts are not just physical in the sense of having mass. They're quantum physical, which means something far stranger is happening in your brain every moment than neuroscience currently imagines. The quantum nature of consciousness has profound implication for the relationship between information and physical reality, because quantum information behaves in ways that classical information cannot. When two quantum systems become entangled, they form a single unified state that cannot be described by specifying the state of each system separately. The information about the combined system is irreducibly holistic. It exists in the correlations between the parts, not in the parts themselves. If your conscious experience arises from quantum processes in your brain, then you are a web of quantum entanglements. The neurons in your visual cortex processing this text are quantum mechanically correlated with neurons in your language centers and memory systems. The whole pattern forms a unified quantum state. This quantum state has mass, not just because each bit of classical information weighs something, but because quantum information carries energy in a more fundamental way. A quantum superposition represents potential energy that collapses into kinetic energy when measured. The act of conscious observation involves a physical transition with real energetic consequences. Every time you become aware of something, every moment of conscious experience, you are collapsing quantum superpositions in your brain. These collapses release energy. The energy is tiny but ton-go. Your consciousness is actively doing work on the physical world simply by experiencing it. This connects to a deeper principle about information and reality that I think most people don't appreciate. Information is not separate from the physical world. Information is the fundamental currency of physics. When you describe the state of any physical system, you specify information, the position and momentum of a particle, the spin of an electron, the polarization of a photon. These are all information. Physics is fundamentally about how information evolves and transforms. The laws of physics are rules for how information propagates through spacetime. Quantum mechanics tells you how quantum information changes when systems interact. Relativity tells you how information travels through curved spacetime. Thermodynamics tells you how information relates to energy and entropy. Everything physical is informational and everything informational is physical. There is no dualism here. Matter and information are not two separate substances. Matter is organized information. Energy is the capacity to transform information. Space and time are the arena in which information evolves. Your thoughts exist as patterns of information encoded in the physical state of your brain. Those patterns have mass because information has mass. They curve spacetime because mass curves spacetime. They obey conservation laws because information is conserved. But here's where it gets truly strange. If information is physical and consciousness involves quantum information processing, then consciousness itself might have gravitational effects that we haven't yet measured. The collapse of a quantum superposition is called wave function reduction, or collapse. In standard quantum mechanics, this collapse is instantaneous and doesn't involve energy or time, but I've proposed a different picture. I suggest that gravity itself causes wave function collapse. When a quantum superposition involves two states with different mass distributions, they create different space-time geometries. At some point these geometries become incompatible, and the superposition becomes unstable. Gravity forces a choice between the alternative geometries, and the wave function collapses. This process takes time and involves energy. The energy comes from the gravitational self-energy of the superposition. When collapse occurs, this energy is released. The timescale depends on the mass difference between the superposed states. For microscopic particles, the collapse time is extremely long, effectively infinite for practical purposes. But for larger systems involving significant mass differences, collapse happens quickly. This is why we don't see macroscopic superpositions. Gravity doesn't allow them to persist. Now here's the radical part. If consciousness involves quantum superpositions collapsing due to gravitational effects, then conscious moments have a gravitational signature. Each time you think, each time awareness arises, there's a tiny pulse of gravitational wave emission as quantum states collapse. These waves would be far too weak to detect with current technology, but in principle they exist. Your consciousness is radiating information into the geometry of spacetime itself. This means your thoughts are not confined to your skull. They leak out as gravitational ripples propagating at the speed of light. The information is scrambled and diluted, but it spreads through the universe carrying a trace of your conscious moments. Everything you've ever thought has left an imprint on the structure of spacetime. That imprint still exists, propagating outward as an expanding sphere of gravitational waves. The information is encoded in curvature fluctuations too small to measure, but real nonetheless. This is what it means for information to be physical at the deepest level. Your subjective experiences are not private mental events separate from the physical world. They are gravitational events, mass rearrangements, energy transformations occurring in the fabric of reality itself. Some philosophers argue that consciousness is immaterial, that subjective experience cannot be reduced to physics. But I think they have it backwards. Consciousness is not less physical than matter. It might be more physical, more deeply connected to the fundamental structure of spacetime and quantum mechanics than ordinary matter. When you see red or feel pain or understand an idea, something is happening in the physical world that goes beyond mere information processing. There is a collapse of quantum possibilities into definite outcomes. There is a gravitational signature of mass rearrangement. There is energy transformation and entropy change. All of this is measurable in principle, even if not yet in practice. Your thoughts have mass, they occupy space, they take time. They obey physical laws. They are as real as electrons and photons and gravitational fields. This also means that the hard problem of consciousness, the question of why physical processes give rise to subjective experience, might have a physical answer. If consciousness is fundamentally quantum gravitational, if it involves a process that cannot occur in purely classical or purely quantum systems alone, then perhaps subjective experience emerges from the interface between quantum mechanics and gravity. That interface is not yet understood. We don't have a complete theory of quantum gravity. But when we do, I suspect it will tell us something profound about consciousness. Not that consciousness is explained away or reduced to something else, but that it's revealed as a fundamental feature of how quantum information interacts with space-time geometry. Your brain is the most complex structure we know of in the universe. It contains more synaptic connections than there are stars in the galaxy. It processes information through electrochemical cascades involving trillions of molecular interactions per second. And underlying all of this, I believe, are quantum processes that make your consciousness genuinely quantum mechanical. Those quantum processes involve real information with real mass. Every thought increments the total mass energy of your brain by a femtogram or less. Every memory formation adds gravitational mass. Every act of forgetting releases it. You are not separate from the physical world. You are not a ghost in a machine, a disembodied soul piloting a meat robot. You are the physical world becoming aware of itself. You are information given mass and energy and the capacity for self-reference. And information, we now know, is as physical as anything can be. It's conserved by the laws of physics. It has energy and mass. It shapes spacetime. It cannot be created or destroyed, only transformed. Your thoughts are not less real than rocks. They're just organized differently. They're information in motion, quantum correlations collapsing into classical patterns, mass rearranging itself into structures that can know and feel and wonder. That's what you are. That's what consciousness is. Physical through and through, strange and quantum and gravitational, but ultimately made of the same stuff as everything else, information given form, reality knowing itself,